Hello again, higher algebra students. Back here with Unit 8, Lesson 4, which is factoring by grouping. So a couple of things that we're hoping to be able to accomplish here today is to be able to complete all the steps to factor by grouping and to really be able to factor when that a value is not equal to 1. So that term in front of our x squared, when that is not equal to 1 and does not have a greatest common factor to pull out of there, or a perfect square for that matter. So in terms of the steps to factor by grouping, so when we look at a polynomial like this here, ax squared plus bx plus c. So for instance, if we had 3x squared plus 10x plus 8, what we are going to do first is to get a product of a times c. So in this case, that would be this 3 times this 8. So we have a product of 24. Okay, so the next step is to determine which two values we are going to take that multiply up to 24, but also add up to 10. So this is also known as the AC method, where we get the product of a times c, but we're going to look at the factors of 24 and look at which two factors add up to 10. So we look at all these pairs of factors of 24, and we see the two that add up to 10 are 4 and 6. Okay. So what we're going to do with that 4 and 6 is we're going to rewrite the polynomial. Again, this is the exact same one as we started with, but we're splitting up that 10x in the middle and writing it with a 4x and a 6x. So it's the exact same problem. We're just splitting that. Okay. And then we're going to rewrite this in two groups. So we've got the first two terms in that first one, and then we're always going to put a plus in between them. Okay, even if there's a negative here, we're going to put a plus, and it just makes your life easier down the road to not put a minus in there if it were a minus. So write it as a plus, but then just put the negative inside the parentheses if we have that. But for right now, it's all positive, so we put the plus there, and then we put in parentheses the last two terms, the 6x plus 8. And then we're going to find the greatest common factor in each set. So for that first set, the only thing that goes into both of those is an x. Okay, so that leaves a 3x because it was 3x squared, and we just pulled out an x. So there's a 3x left, and it was a 4x, and we just pulled out an x, so that's now a 4. On the other side, they don't both have x's here, but they do both have a 2 that goes into them. So a 2 goes into 6 and 2 goes into 8. So we're going to pull out that 2, okay? And then what we end with is we factor out that common term. So when we factor out that common term, you can see 3x plus 4 shows up in both of these. So that gets factored out, and we take what's left, which in this case is an x, plus a 2 here, and that becomes the other term, okay? And again, there is no plus sign in between these anymore, because what happened is the x was multiplied by the 3x and the 4, as you saw right there, and the 2 is multiplied by the 3x and the 4, which you saw in that second term. So it's all multiplication, so it does end up with the foiling that would bring us back to our original polynomial. But this here would be our final answer. That is now factored in a situation where a does not equal 1. And here, if you did switch around or swap the 6x and the 4x, it would not change our answer in any way. You would end up with the exact same thing, so don't worry about that here. So now what I want to do is factor out the biggest term I can out of each of these. And again, part of the reason I do this plus here and then go to the minus, you'll see, has to do with if I put a minus, excuse me, Then again, I'm always going to put a plus in between these, okay? So the plus and then another set of parentheses just makes our life easier when we start to factor things out. And if we put a minus there, since we're subtracting the whole parenthesis term, it will change the sign in front of the 10, and so it makes our life more difficult. And I'll just kind of leave it at that for now, but just always put a plus in there. Now I have to figure out a plus right here, sorry, and then just leave these as a negative here and a negative here to represent those minus values right there. So now I'm going to factor out the term that comes out of each, and what comes out of the first term here would be just an a. So that leaves 6a plus 5. Again, if we distributed that a back in, we'd have 6a squared plus 5a, which is exactly what we want. Now again, we have this plus. Now keep in mind, we want this parenthesis to also be a 6a plus 5. And so can we pull that off here? Well, yes. If we factor out a negative 2, and again, you're always going to find it's a little easier to factor out the negative whenever we can. So when we can leave these terms positive inside the parentheses and just factor out the negative, that makes our life a little simpler. And of course, here it had to be that way because the 6a plus 5 had to match for both of these. So with that, we can then factor out the 6a plus 5 here, and then whatever's left, which is an a minus 2, becomes the other term, okay? And that's the a and the negative 2 there. So to check this in the end, we could FOIL. We have 6a times a is 6a squared. Outside would be negative 12a. Inside would be a positive 5a. And last would be a negative 10. So again, these two are the same, except I just switched around the negative 12 and the 5 in the middle. But ultimately, negative 12 plus 5 here is a negative 7a, which is what it was originally in the question. So that means that we have done this correctly. Moving on to one more grouping here that we'll do a little quicker, and there's a couple more to follow, but just another grouping here. So AC here is going to multiply to 60. Again, the factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. But again, we need them to now be negative 19 in terms of what they add up to. But again, they needed to multiply to be a positive value, so we need two negatives. So in other words, which of these pairs of values, if they're both negative, would they add up to negative 19? Well, that would be right here, the 4 and the 15. So negative 4 and negative 15 is how we're going to split up B. And again, when you multiply those, they'll end up being a positive 60, which is AC. And of course, if you add them plus a negative 15, you're going to get a negative 19, which is what our B value is here. So when I rewrite my polynomial here, I have 6m squared minus 15m minus 4m, and again, it doesn't matter if you go minus 4, then minus 15 or vice versa, and then plus 10. So from here, I'll group them. And so I'm going to put in parentheses 6m squared minus 15m plus, and then in parentheses, negative 4m plus 10. Again, I always put that plus in between here, and then just carry that minus into the actual parentheses there. So I look at this first one. I know I can carry out an m, but I can also carry out a 3, because 3 goes into 6 and 3 goes into 15. So that gives me 2m minus 5. I know I can't go any further than that because there's nothing that goes into both 2 and 5 besides the number 1. So I'm going to put a plus there. And again, I want inside my parentheses to be 2m minus 5, okay, so that these two will match. So what do I pull out? I'm going to pull out a negative 2 here because negative 2 times 2 is negative 4, and negative 2 times a negative 5 is a positive 10, which is what that term was right there. So from there, I am going to factor out the 2m minus 5, and what's left there is 3m minus 2, okay, these two terms here. And again, if I FOILed that, my middle terms would be a -4 and a -15, which ends up being -19. And my L, my last terms here, -5 times -2, is a +10. So again, we have done that correctly. Moving on, without the prompts here, again, AC is going to be 36. Okay, so the factors of 36 are 136, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. But I need two that add up to 13. So everything's positive here. So I just need two that add up to 13, and the only ones that add up to 13 are 4 and 9. So I'm going to rewrite this as 6a squared plus 4a plus 9a plus 6. And again, now I'll group them. And when I group them, I could have done this on the same line, but again, I'm just getting so used to putting the pluses there. I'm just rewriting it like that. But again, you could have technically, especially when it's all pluses, it goes pretty easy to group right there as well. But if there are minuses in there, it's always going to be easier to just rewrite. Okay, so now I need to figure out what factors out of each. And out of this first one, as two even numbers, I can factor out a 2a. So that gives me 3a plus 2. So that's plus. And then again, if I want to have another 3a plus 2 over here, what can factor out of there is a 3. And that works out well. So that means we're on the right track with this. And so then I take my 3a plus 2, and then what's left is a 2a and a plus 3. Again, if I were to verify this, my outside terms add up to a 9a, my inside, or multiply to a 9a, my inside terms multiply to a 4a, which brings me to 13a. And 2 times 3 as my last terms is a plus 6. So again, that is correct. Last one, this one does have a greatest common factor component to it. So if you see this, you could recognize it right away and pull out a 3. Okay, and if you do that, then we've got x squared minus 3x minus 4. And now we're just trying to figure out what multiplies to -4 and adds to -3. So it would just look like this. Okay, and that's great. If you recognize the greatest common factor, that is great. But we can also pull it out at the end. And here's what I mean by that. If you don't recognize it, in this case, AC is 3 times -12, or -36. And the factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Well, we need them to add up. One needs to be positive and one needs to be negative, because they need to multiply to a negative number. And they need to add up to -9. So where is there a difference of 9 between the two? And that would be right here. And again, it would have to be a -12 so that we get that -9. Okay, so when we group this, we would have, oh, I don't need that, we would have 3x squared, and I'll do the plus again first. So I have plus 3x minus 12x minus 12, again, because minus 12 was the actual last term. So I group this, and I get 3x squared plus 3x, and then I'm always going to put that plus sign, but it's a -12x that came next, minus 12. Okay, so what can I pull out of these? Well, the first one, I can pull out a 3x, and that just gives me x plus 1. Okay, so what can I do to make this an x plus 1? Well, to make this an x plus 1, I can pull out a -12. Okay, so what I get here then is x plus 1 and 3x minus 12. Okay, and again, I matched these terms here, and by pulling out the -12, there was a -12 and there was a -12, or a negative and a negative, so that was what allowed me to do that. Now, what you'll notice here is this second term has something that we can factor out of it, which is a 3. So I would here have an x plus 1, but then out of the second term, I can make this x minus 4 and factor a 3 out of it. Okay, now if you were to rewrite this the way we typically see it, then it would look like this, which of course is a match for what we did up at the beginning. So the long story longer with this is I could have factored out at the beginning and made my life a lot easier probably, or I can just recognize that I have to factor out at the end and I'll get the same answer. Okay, now just moving on quickly to the idea of cubic polynomials. So if you have something that is raised to the third power, okay, what you can do with that is actually it's a little easier process is you just group the terms to begin with. So you don't have to do the AC stuff. You would just group them to begin with. You'd pull the common factors out of each. So again, you can see I had the 4 terms there. I grouped them into 2 sets of 2. I pulled the common factor out of the first set, and then I pulled a common factor out of the second set. Okay. And then I did the same thing where I just factored out that x minus 4 and left the x squared plus 3 to go from there. So there are times where you may be able to reduce or factor out from here, but it won't be that case in all the time. This may just be our final answer like it was here. Just a couple examples of that. If I group the first two here, and so I have 12a cubed minus 9a squared, and then again, I'll always put that plus there. And then I have 4a minus 3, okay? So I pull the factors out of each. So this first one, I can pull a 3a squared out of this because this is a to the third and a squared, and 3 goes into 12 as it does into 9. So if I do that, that leaves me with a 4a, because 3 times 4 is 12, and then a minus 3. And again, it's just minus 3 because 3 times negative 3 is negative 9, and the a squared's along for the ride. So my hope is that I can get a 4a minus 3 over here. Well, that's what it already is. So that's just a 1 in front. Now, that 1 in front is important because when I pull out the 4a minus 3 down here, I do still need this 3a squared to be matched with something over here. So that's a 1. Again, if there weren't a 1 there, then we wouldn't multiply this 4a minus 3 on the right side when we go back through. In other words, this and this go together. But if I didn't have this plus 1 here, then I'd be missing the other terms of the foiling because I wouldn't have what would be the outside or the last multiplication to happen. So for instance, I wouldn't get this minus 3 up here because I wouldn't have had a negative 3 times anything had I not put that 1 there. So you do have to make sure that even though we already had 4a minus 3 here, you do have to pull out a 1 automatically there. Okay, so quickly a couple more. Here, 2p to the third plus 5p squared, automatically a plus, and then it's 6a plus 15. And from here, I again have a p squared to pull out of this, and a 2 and a 5, they don't have any common factors outside of 1. And so the 2p stays, as does the 5, okay? Now p squared times a 2p would be 2p cubed, and so on. And then we have the plus, and again, we're hoping that we can make this a 2p plus 5. And if we put a 3 out front, that would work just perfectly there. So we get 2p plus 5 is what gets factored out from the parentheses, and that leaves a p squared plus 3 from these two terms right here. And again, if we FOILed that, we would end up with our original 2p cubed plus 5p squared plus, 6p, not 6a, plus 15. Okay, now this one looks a little different. It doesn't have a leading term on that m cubed in terms of an a different than 1, but we can still go about this the same way. So I have m cubed minus m squared plus, and then 2m minus 2. So in terms of what to pull out from here, from the first one, it's just really an m squared. So that leaves an m for my first term, but I also, again, still have a minus 1 there because that m squared needs to be multiplied by a negative 1 to get the minus m squared that we started with. And then plus, and again, hopefully this m minus 1 works, and it does with a 2 out front. So this would just be m minus 1, and then m squared plus 2 as the two terms that were left there. So I'll leave it at that. Thank you again for listening, and if you have any questions, as always, please just ask.